This is Moreland Engineering, and today we're going to make a little more progress on our 350Z aero model for Grassroots Motorsports. For those just joining us, Moreland Engineering is a race car engineering firm. We focus on vehicle dynamics and aero development. For the most part, our work currently is in converting existing cars to CFD models so that we can run them in our virtual wind tunnel. Sometimes the output of that is custom components or selection of off-the-shelf components, and other times it's to develop a custom aero manual for trackside use. We can cover that in another video. So let's get started. Previously we roughed in the roof, windscreen, hood, deck, and bumpers, and then we X-formed them into place. So let's hide those for the moment. After that we worked on the side, and now we're going to try and get a corner roughed in. So the side is longer than we need, and it doesn't match. We've only matched the meat of it, the most wide portion of the side. So let's trim that down to just what we need. We're kind of guessing on this for the moment. Again, all this is parameterized, so we can go back and adjust it later. We'll probably want to come back and cut this off also, but again, we'll look at that later. For now, let's just get it down to size, and that mostly covers the part of the side that we need. Tune that up just a little bit. There's a good chance we'll just make it worse. Or no change. We're not capturing all of the end of this surface. There we go. Let's try that. There. Now it follows it right up to the edge, or closer to the edge anyway. Now we've got all these highlight lines that we've created in sketches, and we need to get them on the body. For this case, we intersected a top view and a side view, and we've got this really nice highlight line that runs the length of the body, and it follows the body pretty well. We can tune it up here and there as we go, but for the most part this gets us where we need to go. So how do we do that here? Well, these fender wells have a curve and a taper to them. So let's just get something in there. Now this is a sketch I made earlier on the wheel center line. I do the same both ends. You'll notice that it doesn't really match, but we can fix that. We know generally that this is a convex shape, so we can just start in that direction. Get a few more control points in there so we can get it a little tighter. And this is set to proportional, so when I move one point, it's moving nearly all of the points at least a little bit. That helps keep the surface nice and smooth, even when we're getting pretty aggressive with the modifications. And that keeps us from having to go back and chase individual little knot points, which can turn into a real nightmare. Sometimes it looks a lot worse before it gets any better. There we go. We're almost matching it. That's going to be close enough for now. May as well do the back while we're at it. This one's a little different because it blends heavily into the rear bumper. Sometimes the proportional is helpful, and other times it can make life difficult. I'm going to need another set of knot points here. That's pretty good. We can probably live with that. Arguably better than we did on the front. So, now what? I'm going to tune this in just a little bit more. We really don't care what happens in the middle of it because we're only after this little edge. Once the edge is happy, the middle we're just going to hack away. But we do want to pay a little bit of attention to the overall curvature because it's going to impact any other surfaces that we attach to this one. Let's call it a day. Alright. Now that we've got that, we can trim each of these. Now we have some nice surfaces to work towards. Now this bumper has a nice highlight line. You can see it show up right here. So we can do the same thing. We've got a projected curve. We've taken these two curves, directed them at each other and intersected to get us this nice line that vaguely follows the bumper. Now that we have this curve to work towards, we can segregate just the portion of that curve and we don't know that these curves are intersecting with our section curves, so we can't use a through curve mesh or probably a studio surface either, but we can do a sweep because sweeps follow the section and the curves are generally just guidelines. Now we have a top and a bottom one because the curvature changes. It's sharper at one end than it is at the other. And again, we can come back and tune that up with the next form as we go. So let's just work our way around. We can do the same thing to our major highlight line. Let's shorten it up to a workable section. And I think we can hide the sketch for the moment because it's kind of in the way. Now that we have some curves, ooh, that's not where I wanted that. Just leave that there. We're going to work from here to here, but we need to capture that profile. So let's just do a sketch. We're going roughly from here to here. We want to capture the concave portion of it, not so much the convex portion, because the convex portion we can work into the blend when we blend it into our outer wheel arch there. Now we'll try our second favorite tool for today, the sweep. Give it a section. That gets us most of the way there. It's turned convex at the back. That's either because we're trying to do too much or just because the guide curves are opposing our section here. There are some sections here. Sorry, there are some settings here that change the shape of that. None of them seem to be better. Let's try a different feature. Studio Surface works better sometimes. It's a little different math in how they achieve their goal. So that gets us pretty well there. Now let's work on the back. So we're really just trying to cover as much of this surface as closely as possible, and then we can patch the pieces together. In this case, we don't really have a guide here. So we can do a bridge curve on the bottom edge here. And we're going to use G2, which is curvature continuous back here, and up at the front G0 because we don't want any tangency there. We actually want a hard line that we can come back and blend. Something like that. We don't really have anything to work to up here, we could do the same thing, but we might end up twisting that curve in 2 dimensions. So let's get something that's on plane here. We can follow those lines, project them out to here. Now we've got something we can work towards. Again, we're G2 back here, G0 up at the front, and now we have a surface that we can trace. So we're going to try and follow the curve of our STL as much as possible. Go back to our studio surface. Now, when you only have 2 sections, it tries to incorporate the entire length of the section, which is why we've been shortening up things. But as soon as we add a guide curve, it limits that. And we want tangency on the one surface. Notice the difference. If we don't have tangency, it only goes by the guide curves. But if you use tangency, G1 or even G2, it follows the curvature of the surface attached. And that's getting pretty close. We've still got a hole up here. Now this is problematic because we essentially have this intersecting triangle, and we can't really make a 3-sided surface. We can, but to get it tangent on all sides is not possible. Nearly impossible. Same with the front. We have this awkward little patch. Now the front's a little bit easier because we've got a headlight in the way, and the headlight doesn't follow the surface of most anything. It's sort of its own little knot there. So we can kind of do whatever we want behind the scenes, behind the curtain of the headlight. We can get pretty aggressive just trimming things and attaching. First off, let's tune this in a little. Now, we followed the intersection lines. We're working to the intersections on either end. Yikes. But we want to adjust our surface. So we can apply constraints. We can keep it on the edges that we chose and just manipulate it in between. Nope. We want to keep that proportional. If we wanted to get really crazy, this would allow us to capture the reflex, the concave to convex shape, but I'm not sure we want to try and do too much in the one feature here. With a surface that reflexes from concave to convex, it can be very tricky to get it all to agree, especially with the proportional setting. The good news is we're going to chop the back out of this anyway, so we don't really care how close it is back there. We just really want it nice in the middle. That's pretty good. Alright, now, again, we're going to go back to this curve. Let's hide these because we don't want those getting in the way. Now, let's set some new limits from here to say here. Now, everything from here back we're pretty happy with. Everything from say here down we're pretty happy with. So let's create a datum. In this case, we're just going to give normal to our curve and chop it. But in this one, we want a little different orientation there. Move these off somewhere. Now I've got something to work with. So again, surface, studio surface. Here to here, guide here, tangency there, tangency there. We're going to need, can we get G2 here? We can. It looks lumpy though. I'll stick with G1 for now. That's not doing what we want, so we're going to need to add some control. That gets us pretty close, and now we have this lever we can pull to adjust. Steepen that up, steepen that up. Pull it back. Pull it back. Not terrible. It's not perfect, but it's not terrible. And then again, we're going to come and carve out the headlight orifice anyway. Put this little shelf in here.